Alright, and welcome to Coordinate Relationships, Level 1. Now, in problem number 1, it says, given the table below, which of the following is false? Wait a second. So if you find something is true, and you're going to be tempted to circle that as the answer, be careful. We're looking for something that is, in fact, false. Now, in order to save time, what I'm going to do is I'm going to set up this video every time I start a new problem, so we can save a little time. But the thing that we want to do first is we want to go look at the answer choice, and we want to see what is this question asking. And the answers all say the same thing. Is PQ congruent to RS? And it's the same thing here. Is PS congruent to QR? Is PR congruent to QS? Is RP congruent to SQ? Now the next thing you want to do is you always want to be on the lookout for doubles. What do I mean on the lookout for doubles? And I want to draw your attention to letter B and letter D. Here we have line segment PR, and I look here and I have line segment RP. That's the same line. Remember, for line segments, the order really doesn't matter. And here I have line segment QS and line segment SQ. And so I know right off the bat, I actually don't have to worry about one of these. More often than not, I wouldn't have to worry about both of them. But, you know, let's just be careful here. Okay, now let's go ahead and start tackling these problems. Okay, for letter A, so I'm not circling it because it's the answer. I'm circling it because this is what we're going to be testing out. We want to see if PQ is congruent to RS. Now, whenever we talk about the word congruent, what we're saying is, what is the length or distance of the line? How long is it? And so what we want to use is our distance formula, which you can find on your formula chart. Now from here, what I've done is I've labeled the points P and Q and R and S, and I've also labeled them x1, y1, x2, y2, x1, y1, x2, y2. Now let's go ahead and set up our formula. So we have D is equal to the square root of, let's go ahead and work through this, parentheses, x2, 3 minus 5 squared plus, and our y2 value is negative 7 minus 8, and that's, of course, squared. So now I can say, okay, well, D, the distance, is the square root of 3 minus 5 is negative 2 squared plus, and negative 7 minus 15 is actually negative 7 minus 8 is negative 15 squared. Now, you might want to use your calculator for the larger numbers, but I know that negative 2 squared, remember, you have to type it into your calculator as parentheses negative 2 squared. Otherwise, it will return a negative. But remember, negative 2 squared is positive 4. Anytime you square something, it must be positive. Plus, and 15 squared is 225. And then I can say, well, my distance is the square root of 4 plus 225, which is 229. Now that is going to be an irrational number or some crazy decimal. We actually don't have to go any further than this because we're going to see, hey, is this distance the exact same or is it different? Okay, so let's try this one. We have D equals the square root of, parentheses, x2, 1 minus 3 squared, plus, and here my y2 value is 5 minus 20 squared. And I actually noticed something interesting here. When I do 1 minus 3, I get negative 2 squared, plus, and 5 minus 20 is actually negative 15 squared. Wait a second, does that not look exactly like that problem on the left? So what I can assume right here is that the math will be completely the same. So look, the negative 2 squared is 4, and negative 15 squared is 225, and 4 plus 225 is 229. So it's kind of really at this point I can tell, oh yeah, these are actually going to have the same distance, which means that they are in fact congruent, which means it's not the answer because we're looking for the false statement. Okay, so let's go ahead and clear this off and let's go test out letter B. Okay, and notice that I've gone ahead and I've written PR and QS, and I've labeled point P, point R, point Q, and point S, and x1, y1, x2, y2, x1, y1, x2, y2. That should be in your setup always and forever. Label the points x1, y1, x2, y2. Okay, now from here, let's just go ahead. I am going to be a bad math teacher just for a moment. I'm going to drop the D equals. We're just going to write the square root of, so we have a little bit of space. And here, I notice it's x2 minus x1, or 3 minus 5 squared, plus, and here 20 minus 8, y2 minus y1 squared. And this gives me the square root of 3 minus 5, which is negative 2 squared, plus 20 minus 8, which is 12 squared. And by the way, you might be tempted to just plug in your numbers over here as well and stop. I would encourage you to always work these out to the end so that you get the repetition and the practice of solving through these problems, so that when you have to do this in a testing scenario, it's quick and easy. All right? This assignment is all about repetition and getting faster at these processes. Okay, so negative 2 squared, well, we know that that is positive 4, plus 12 squared is 144. And 4 plus 144 is simply the square root of 148, is equal to our distance. Now, you could simplify that, you could get the decimal, but if you get to this point, this is a nice place to stop. Okay, and from here, let's go ahead and plug everything in. So I see my x2 value is 1 minus x1 is 3 squared, plus, and here my y2 value is 5 minus negative 7. Okay, and wait a second, two negatives actually make a positive. And so here I have the square root of 1 minus 3, which is negative 2 squared, plus 5 plus 7, which is 12 squared. And once again, it's at this point I know, hey, these are definitely going to turn out to be the same. But I cannot stress this enough. Work them all out, get the repetition so you can get faster at solving these problems. And so we have the square root, negative 2 squared is 4, plus 12 squared, that's 12 times 12, is 144. And then I have the square root of 4 plus 144, 148. In fact, if I were you, I might even practice plugging that into the calculator and getting the decimal. It's going to be 12 point something, 12 point something. If I had to guess, 12.03, but you try it out yourself. All right. Now we know that these two things are the same distance, so they must be congruent. So let's go on to the letter. Oh, and this also allows us to cross out D. So we know by default, letter C must be the answer, but let's test it out and just make sure. Okay, so now we're going to test out, is PS congruent to QR? And we have a strong hunch that it will be, but let's test it out nonetheless. So PS, here's point P, here's point S, here's point Q, and here's point R. And of course I labeled them x1, y1, x2, y2, x1, y1, x2, y2. Alright? And that should be automatic at this point. Now let's go ahead and write this out. So we have the square root of, let's see here, x2 is 1 minus 5 squared, plus, and in this case our y values are going to be y2, 5 minus 8 squared. Okay, working down, we have 1 minus 5, which is negative 4 squared, plus 5 minus 8, which is negative 3 squared. And here, negative 4 squared, that says negative 4 times negative 4. That's going to be positive 16, plus, and negative 3 squared is really negative 3 times negative 3, which is positive 9. And now I have the square root of 16 plus 9, which is the square root of 25. And the square root of 25 is 5. So our distance, this line segment, is actually 5 units long. Okay, let's go ahead and let's go to QR. Okay, I draw my square root symbol. I know that it's x2, which is 3 minus x1, 3 squared, plus, and then over here we have y2, 20 minus negative 7, you want to be careful there, squared. And right off the bat, look, if you're good at mental math, you should see that this will already be different, but let's work it out for the practice. I know that 3 minus 3 is 0 squared, but y'all, 0 squared is nothing, so it just cancels. And here we have 20 minus negative 7, or 20 plus 7, which is 27 squared. Okay, now normally what I would have to do is I would have to square this, but check this out, because this term over here, the 0 canceled, actually what I have is the square root of 27 squared, and a square root and a square cancel, and the distance here is simply 27. If you don't believe me, you can try it out yourself. You can square 27 in your calculator and take the square root of that number, but you will get 27. And we can tell that then, since these two distances are not equal, these are actually not congruent, which means that it is a false statement. Therefore, C is our correct answer. Alright, I believe that problems 2 and 3 are just asking you to find a true statement, So just make sure that you read them and understand what the question is asking. Alright, I'll catch y'all in our level 3 video.